To size service conductors for 6 rooftop units, firstly, determine the total load. Calculate the total load in amps for all 6 rooftop units. Sum the minimum circuit ampacity for each unit as listed in the nameplate. Secondly, apply demand factors. Apply the demand factors from Table 430.25b of the National Electrical Code to the total load. This accounts for the fact that all rooftop units will not operate at full load simultaneously. Demand factors recognize that the total connected load is unlikely to be drawn continuously. Thirdly, consider overcurrent protection. Choose an overcurrent protective device, or OCPT, rated at or greater than the maximum overcurrent protective device value specified in the unit nameplates. Refer to Section 440.6a of the National Electrical Code for allowable overcurrent protection. The overcurrent protection should protect the equipment and the conductors from overloads and short circuits. Fourthly, size the service conductors. Calculate the service conductor ampacity using the formula service conductor ampacity equals demand factor multiplied by total load ampacity. Then divide by the conductor rating. Use the ampacity tables in Article 310 of the National Electrical Code to select conductors with a current carrying capacity equal to or greater than the calculated ampacity. These tables provide ampacity ratings based on conductor type, insulation, and installation conditions. Additional considerations include voltage drop allowed for the service conductors. Install service equipment such as a disconnect switch and OCPT of appropriate size. Consult local electrical codes and regulations for any specific requirements. Now, consider this example: 6 rooftop units with the following minimum circuit ampacities: Unit 1 20 amps, Unit 2 25 amps, Unit 3 30 amps, Unit 4 35 amps, Unit 5 40 amps, and Unit 6 45 amps. The total load ampacity is 20 plus 25 plus 30 plus 35 plus 40 plus 45 equals 195 amps. Applying a demand factor of 70% means demand factor multiplied by total load ampacity equals 0.7 multiplied by 195, which equals 136.5 amps. Selecting overcurrent protective devices rated at 150 amps. Service conductor ampacity using 75 degrees Celsius conductors means service conductor ampacity equals 136.5 amps. The required conductor size is number 2 American wire gauge THHN or equivalent. This example illustrates how to apply the steps outlined to a practical scenario. Remember to consult the National Electrical Code and local codes for specific requirements and to ensure safe electrical installations. Always prioritize safety and consult with a qualified electrician when working with electrical systems. The minimum circuit ampacity listed in the rooftop unit's nameplate provides the necessary current carrying capacity for the branch circuit conductors. This value ensures that the conductors can safely handle the continuous load of the unit without overheating. The maximum overcurrent protective device, also found on the nameplate, specifies the largest fuse or circuit breaker allowed to protect the unit. This value protects the equipment from excessive current that could cause damage or create a fire hazard. Article 220 of the National Electrical Code provides general guidelines for calculating branch circuit, feeder, and service loads. However, Section 440 specifically addresses the requirements for air conditioning and refrigeration equipment, which often includes rooftop unit. While Section 440.6 primarily focuses on branch circuit conductors, it does provide valuable information on selecting the appropriate overcurrent protection for the equipment. To determine the total load, sum the minimum circuit ampacities of all 6 rooftop units. This gives the total current demand before applying any demand factors. The demand factor accounts for the fact that not all units will operate at their maximum load simultaneously. Table 430.25b in the National Electrical Code provides demand factors for various types of equipment, including air conditioning and refrigeration units. The appropriate demand factor will depend on the number and type of units installed. The overcurrent protective device should be sized to protect the conductors and the equipment. It should be rated at or below the maximum overcurrent protective device value specified on the unit nameplates. Section 440.6a of the National Electrical Code provides additional guidance on selecting the appropriate overcurrent protection. The service conductor ampacity must be sufficient to carry the calculated load. Use the formula service conductor ampacity equals demand factor multiplied by total load ampacity. Conductor ampacity tables Article 310 of the National Electrical Code provide the ampacity ratings for various conductor types and sizes. Select conductors with an ampacity equal to or greater than the calculated service conductor ampacity. Voltage drop is an important consideration when sizing service conductors. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The National Electrical Code recommends limiting voltage drop to 3% for feeders and 5% for branch circuits. The service equipment, including the disconnect switch and overcurrent protective device, must be sized appropriately for the calculated load. Consult the National Electrical Code and local codes for specific requirements. Local electrical codes and regulations may have specific requirements that must be followed. It is important to consult these codes and regulations to ensure compliance. For example, suppose you have 6 rooftop units with the following minimum circuit ampacities: Unit 1 20 amps, Unit 2 25 amps, Unit 3 30 amps, Unit 4 35 amps, Unit 5 40 amps, and Unit 6 45 amps. The total load ampacity is 20 plus 25 plus 30 plus 35 plus 40 plus 45, which equals 195 amps. Assuming a demand factor of 70%, the demand factor multiplied by the total load ampacity equals 0.7 multiplied by 195, which equals 136.5 amps. Select overcurrent protective devices rated at 150 amps. The service conductor ampacity using 75 degrees Celsius conductors is the service conductor ampacity equals 136.5 amps. Based on this calculation, the required conductor size is number 2 American wire gauge, THHN, or equivalent. This example demonstrates the steps involved in sizing service conductors for multiple rooftop units. Always consult the National Electrical Code and local codes for specific requirements and to ensure safe electrical installations. Remember to prioritize safety and consult with a qualified electrician when working with electrical systems. Article 440 of the National Electrical Code provides comprehensive guidelines for air conditioning and refrigeration equipment. This article covers various aspects, including branch circuit protection, motor compressor overloads, and disconnecting means. Understanding Article 440 is crucial for ensuring safe and compliant installations of rooftop units. When sizing service conductors, it is important to consider the conductor's temperature rating. The ampacity tables in Article 310 provide ampacity ratings for conductors at different temperature ratings, such as 60 degrees Celsius, 75 degrees Celsius, and 90 degrees Celsius. Choose conductors with a temperature rating suitable for the installation environment. The National Electrical Code defines continuous load as a load where the maximum current is expected to continue for 3 hours or more. When sizing conductors for continuous loads, the ampacity of the conductors must be derated to 80%. This derating factor ensures that the conductors do not overheat when subjected to a continuous load. In addition to the minimum circuit ampacity and maximum overcurrent protective device ratings, the unit nameplate may also provide other important information such as the locked rotor current, or LRA, and the rated load amps, or RLA. The locked rotor current is the current drawn by the motor when it is first started. The rated load amps is the current drawn by the motor under normal operating conditions. This information can be helpful in sizing conductors and overcurrent protection. When installing multiple rooftop units, it is important to ensure that the service equipment has sufficient capacity to handle the total load. The service equipment includes the service entrance conductors, the main disconnect switch, and the overcurrent protective device. The service equipment should be sized to meet the requirements of Article 220 of the National Electrical Code. In some cases, it may be necessary to install a separate service for the rooftop unit. This may be required if the existing service does not have sufficient capacity to handle the additional load. Consult with a qualified electrician to determine the best solution for your specific situation. Grounding is an essential part of any electrical installation. The grounding system provides a low impedance path for fault current to return to the source, which helps to protect people and equipment from electrical shock. The grounding system should be installed in accordance with Article 250 of the National Electrical Code. Bonding is the process of connecting together all metal parts of the electrical system. Bonding helps to create a lower impedance path for fault current to flow back to the source, which reduces the risk of electrical shock. The bonding system should be installed in accordance with Article 250 of the National Electrical Code. Electrical safety is of utmost importance. Always follow safe work practices when working with electrical systems. Wear appropriate personal protective equipment such as gloves and safety glasses. De-energize the circuit before working on it. If you are not qualified to work on electrical systems, consult with a qualified electrician. Understanding the principles of electrical sizing is essential for ensuring safe and compliant installations of rooftop units. By following the guidelines in the National Electrical Code and consulting with a qualified electrician, you can ensure that the service conductors are properly sized and that the electrical system is safe and reliable. Remember to consider all relevant factors, such as the minimum circuit ampacity, the maximum overcurrent protective device rating, the demand factor, the conductor temperature rating, the continuous load rating factor, and the voltage drop. By taking all of these factors into account, you can ensure that the service conductors are sized correctly and that the electrical system will operate safely and efficiently. Remember to always consult the latest edition of the National Electrical Code and any applicable local codes and regulations. These codes and regulations provide the most up-to-date information on electrical safety and installation practices. By staying informed and following best practices, you can help to ensure the safety of yourself and others. In summary, to properly size service conductors for 6 rooftop units, start by determining the total load by summing the minimum circuit ampacities for each unit. Then apply the appropriate demand factors from Table 430.25b to account for non-simultaneous operation. Select an overcurrent protective device rated at or below the maximum value specified in the unit nameplates following Section 440.6a on guidance. Calculate the required service conductor ampacity using the formula demand factor multiplied by total load ampacity, and then consult Article 310 ampacity tables to select conductors with sufficient current carrying capacity. Also consider voltage drop and install appropriately sized service equipment adhering to all local electrical codes. The example calculation illustrates this process. Always prioritize safety and consult with a qualified electrician for any electrical work.